back. Today we're going to be discussing dimensioning standards. Dimensioning standards. In order for drawings to be dimensioned so that all people can understand them, we need to follow standards that every company in the world must follow. Standards are created by these organizations. We have the ANSI, which is the most common, ISO, MIL, DOD, DIN, GIS, and CEN. ANSI is the most common one of these that we'll talk about the most. Standard Institution, ANSI, the American National Standard Institute. This institute creates the engineering standards for North America. ISO is the International Organization for Standardization. This is a worldwide organization that creates engineering standards with approximately 100 participating countries. The DOD is the Department of Defense. MIL is the military standard. DIN is the Dutch and Norway. It's also in Germany. The GIS is the Japanese International Standard, and the CEN is the European Standards Organization. Okay, some different dimension components. We have dimension text, dimension lines, arrowheads, and extension lines. Okay, dimension text. This is what they're talking about here. The stuff that we're actually putting in there. This is what we call a dimension line. An arrowhead has to be at the end of every one of those. And then we have these extension lines. Extension lines are lines that come from the drawing so that we can create a dimension to it. If the dimension text will not fit between the extension lines, it may be placed outside of them. So quite often, instead of placing it here, they'll place it out here off to the side. Typically the number is going to be placed in the middle. Alright, that's not always true, but typically we're going to place it in the middle, both horizontally and vertically. Meaning we wouldn't have the number written down here. Alright, we're going to place it between the lines, and we're going to try to place it between the extension lines. Okay, we've got two different ways that you can put the dimensions in there, and you can change this on Inventor, but most of you are going to probably leave it to the way Inventor does it standard. We have what's called unidirectional and aligned. Unidirectional means that essentially there's one direction. They're going to be going, all of them are going left to right. All right. And then aligned means everything would be aligned with the dimension lines. So notice these are all going left to right. And these are going up and down. Well, the difference here is aligned. They're going to be going in direction with the dimension lines. Okay, classification of dimensions. There's two things here. Typically we dimension to give size. Or the second thing we do is we dimension to give location. So down here you can see they're telling us, for example, this drill bit. All right, if they're going to place a hole here, they're giving us location dimension. This gives us a location. This gives us a size dimension. All right, so that's important. We give those two things. Linear dimension, chain dimensioning. Dimensioning from feature to feature. Common dimensioning technique. Chain dimensioning method. Method 1 and method 2. All right. Well, over here on the left, method 1. We've got, here's a chain dimension, and then here's another chain dimension. They've got three dimensions chained together. Over here they've got three dimensions chained together. I know, we've learned not to do this. Method 2 is they leave off one of those chain dimensions and they still give an overall length of it. Over here they're leaving off a third dimension so they can still give an overall length on it. So this is method 2, is where they leave off one of the dimensions and give an overall length. Thing I want to point out to you down here is if you are going to chain dimension, method 2 is the preferable chain dimensioning method. Alright, method 2 where they leave off one of the chains and still give an overall length or an overall height, or it could be depth as well. Datum dimensioning. Dimensioning from a single point on origin called a datum. I'm not going to spend a whole lot of time with this. We know what datum dimensioning is. It's what we've done primarily. But here's datum dimensioning. They're going from the left. They're going from the bottom as they work their way across. Dimensioning symbols. Alright, you're going to want to get these down. We'll be taking a quiz over these over the next couple days. Not all these will be used, but some of them will. So I would spend some time going through these. These right here are symbols that would go with the dimension. For example, you've seen the diameter, the radius. We haven't done any drilling of holes, so you haven't seen these yet. But these are all ones that we'll be using. Dimensioning angles. All right, there's two methods to dimensioning angles. We have the coordinate method and the angular method. Down here on the left is the coordinate method. From this, it just simply is the same thing essentially as datum dimensioning. They're giving a length, a dimension from here to the top, and then to the top of the, or to the bottom, and then here they're giving it to the top. This is essentially datum dimensioning. All right. Over here on the right, notice that they get rid of this 0.5. All right, and instead of giving a 0.5 here, they give an angle measurement. So either one of those two would be acceptable methods. Chamfers, all right. There's ways you can do this. Two options. Quite often this will be a method you'll list, but you'll see the other one as well. All right. Well, they'll show, they'll give the angle. All right, they'll lead it out as an angle. And what they're telling you here then is this 0.125, they're telling you that from here, that this right here is 0.125, and then from here to here is 0.125. The other way that they would go about doing this is giving an angle measurement and then giving the overall length of it. All right, from the beginning of the chamfer to the end of the chamfer. Okay, things I want to point out to you here with this. Arcs and circles are dimensioned in views that show the arc or the circle. Arcs are dimensioned with a leader to identify the radius. A center mark is sometimes included. Circles should always have center marks. All right, and are dimensioned with a leader to identify the diameter. All right, so we need to have this leader. All right, a lot of people I see on circles are still trying to dimension it like this, whereas for a circle you should have that leader. You should have a center mark, and then you should have your measurement right there, and it's going to have the diameter symbol there. Here's an example of arcs. Notice they went ahead and gave a center mark here. They're telling us it's a radius of 0.5. This is not very common here, where they give the center mark and tell us a radius of 0.5. A lot of times it's going to still be on the outside like they do over here. Radius of 0.125, radius of 0.125. Use the capital R to indicate radius. Fillets and rounds. A fillet is an inside, a round is an outside. So this right here is a round, this is a fillet. We use the same button on Venner to do both of those. But the things I want to point out to you here is, again, here they have this center point, here they have a center point, here they don't. And some of that's going to be a little bit arbitrary, all right? Meaning it's going to be a little bit up to you. Dimensioning circles. Again, they've got the center point there. So cylindrical parts may be dimensioned in this manner. All right, they're showing the diameter because it's a little bit easier to see. Note that the diameter symbol is used so the dimension is not assumed to be linear. All right, so make sure if you do it this way, you have to use that diameter symbol. Okay, if you're doing a spline or a curve, what's going to happen is you're just going to simply pick points along the way. Points are placed along the contour of the splines and dimensioned from a datum. All right, a datum meaning you use datum dimensioning, and it's just the easiest way we have to do it. Here's an example of where someone did the windshield and they picked the datum being right here, so everything was derived off of that measurement. Okay, there's two more things I want to go over. X typically means something's repeated. On here, they're saying they give the dimension for this hole and say 2 times, which means it's this hole and this hole. Down here, you see the symbol that we'll use for drill bits. The last thing I want to go over here is dimensioning radial patterns. Angles and radius values are used to locate the center of radially patterned features. So even though we have a circle here, they're giving a radius because it's not going to, inventor's not going to read it as a circle because we have all these things breaking it up. So it's going to be read as a radius. We'd want to give angle measurements as to what angle are our holes being drilled at. These are each representing a hole that's being drilled here. So hopefully that was informational. I'll catch you on the flip side.